All right, so we are looking at data distribution, and this is Unit 8, Target A. We're going to be looking at two main types of ways of distributing data um, or representing it as well. Okay, so just a little intro. Statistical tools are used to quickly summarize and gain insight about a set of data. In other words, if you have a long list, sometimes it's hard to interpret it. So we have graphs and different ways of being able to read it quickly and get all the information efficiently. All right, so today we're going to learn about two ways, the bell curve and the box and whisker plot. All right, so the bell curve, the basic idea is like when you're talking about grades, for example, if these would be the low end, these would be the high end, and most people would fall kind of like in this middle range. So the height of the curve represents the number of instances of, like, let's say that the mean here was, let's just go with like a test and say it was like 70%. So most students would be in this 70% range. All right, so standard deviation is how far it deviates from that mean. The mean is the highest point on the bell curve. Standard deviation would be like 15 in this example, would be 15 in either direction. So one standard deviation goes both ways, one. Okay, so it goes that way and that way. So, and you would add 15 and subtract 15. So one standard deviation would be from 85 to 115. Two standard deviations, and you'll notice, okay, so we've got 15 here, 15 here, and this would be 15 as well. The next standard deviation, you would add another 15 and subtract another 15. Okay, so like this would be your smarter people, and this would be your, well, let's be politically correct and say not as smart. And then if we did another 15, that would be three standard deviations. Okay, these would be the people with like genius level intellect. So this is like IQ. And going down another 15, that would put us at 55. And those would be people who have a cognitive disability, which is the politically correct way of saying it. All right, so here's a basic rule. It's the 68, 95, 99.7 rule. So 68% of your people are going to fall within one standard deviation. 95% are going to fall within two, and 99.7 are going to fall within three. So then you could have your outliers that would be that 0.3%, could be like way out here or way down here. But the main three we're focusing on is 68, 95, 99.7. So regardless of your data, 68% of it is always going to represent one standard deviation. All right. All right, so here's an example. This is a chart of minutes to get to the office. All right, and then along here you have the number of days. So for example, we had, if this is 80, this is 100, this is about 90, so just shy of 90 days. It took about 43 minutes to get to the office. And then we went down and, about, this would be about 75, this would be about 75. So you kind of get the idea as to what this is. If we took the number of days and say this represented maybe over 2 years, so close to 700 days or something like that, this study was done, and then you could say, well, okay, so here's 75, here's about another 75. So for 75 of the days, it took about 42. For another 75, it took 44. Then for about 62, it took about 62 minutes. And for about 70 days, it took about 45 minutes. So you get the general idea. When we put all this data together, we put it in the shape of kind of like a bell, hence the term bell curve. Okay, one standard deviation would be 37 minutes. And, one standard deviation would be 40 minutes. Another standard deviation would be 46. So that means that we've got +3 and -3. So if we took that 46 and added another 3, that'd give us a 49. If we subtracted another 3, that'd give us a 37, and so on and so forth. All right, so let's take a look at an example. You took a plan test in the fall. Normal distribution of the data is shown below. What percent of the student population falls within 3 standard deviations of the means? Okay, so I didn't actually put any numbers here, okay, because I didn't want anyone to feel bad or anything, or feel like they're really, really smart. So this is just for the purpose of this problem. So remember our 68, 95, 99.7 rule. 99.7% of people are going to fall within 3 standard deviations. So that would be your answer. Okay, if you take an ACT test in the fall, what percent falls within 1%? Again, remember the 68, 95, 95, or 99.7 rule. So one standard deviation is 68%, and that's going to fall in there. All right, so that's basically a bell curve. The main thing you need to remember is, let me go back and just kind of reiterate it. This is the main thing here, okay? You need to memorize this. So this is 1 standard deviation. This is 2 standard deviations. This is 3 standard deviations. All right, so now we're going to move on to box and whisker plots. And luckily, you guys won't actually have to make them. One term you're going to hear a lot of is spread. And spread is going to be the maximum value minus the minimum value. So basically, of all the data, you take the highest one and subtract the lowest one from it, and that'll give you the spread. So like the highest here is 100. So you would subtract 60 from it. So the spread would be 40. Okay, so in our, as far as how box plots are constructed, like let's say we had this long list of numbers here. First thing you would have to do is put them in order. All right, and then you want to count them. If you have an odd number, that would, let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So we have 19. So we would take 19, okay, so there's 19 numbers, divide it by 2. Okay, forget about the decimal place, just look at this number first. So it's actually 9.5. So we would count in 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that next number, that's your mean. Okay, the minimum is 7, and the maximum is 29. And like I said, the median, not the mean, the median is 20. Okay, mean is something different. The median is always the middle. Okay, now if you had an even number, say we added one more number to that. Let's say we added another 29. Okay, that would mean that we'd have 20 numbers divided by 2. That would give us 10. Okay, so we would count to the 10th number, which is 20, and then we would count one more, and we would add the 2 together and divide by 2. So if that were the case, the median would be 20.5. Okay, but we don't have that for this problem. I was just giving you an example. We have an odd number, so it works out really well. And then you're basically going to split this into quartiles. Now think of quartiles, think of the way the word is. Okay, there's quarter, which is 1/4 of a dollar, and quartiles is basically 1/4 of the data. So if we had 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers here, that would mean the middle of that, okay, the 5th number, would be your first quartile. The median is technically the 2nd quartile, and the 3rd quartile would be the 5th number from here, 26. So basically there should be an even number. The numbers should be the same here, here, and here, meaning there should be 4 of them. Okay, you don't include the minimum and the maximum, but between the quartiles and the median, there should be the same amount of numbers. So there's 4 here, 4 here, 4 here, and 4 here. All right, and then you would take your median, and that would be your middle line. And then you would take quartile 1 and quartile 3. Those would be your next 2 lines. And then your minimum and your maximum would be the whiskers of it. All right, so it's not going to be something that always looks even. Like if you look at this one, this length here is much shorter, or longer, I mean, than that length there. So don't expect it to look like this nice even box all the time. All right, so let's take a look at the 3rd example. You don't actually have to construct it in these examples, but you do have to interpret it. So we want to compare the center of the 2 data sets. The center is the median. So in this one, if we go down, if this is 60 and that's 80, this has to be 70. So Lakeside is 70 because this is Lakeside Electronics, and Ortega Electronics has their median set at 80, which is greater. So Ortega has a greater median or center, And then the spread, remember what I said, it's the maximum minus the minimum. So if we look at Lakeside Electronics first, we have 100 as a maximum and 40 as a minimum. So 100 minus 40 is 60. If we go to Ortega Electronics, we have 100 as a maximum as well, but 30 is a minimum. So that would be 100 minus 30, which is 70. So Ortega Electronics has a greater spread with 70. The maximum value for Lakeside Electronics, we said, was 100. Okay, so that's easy to answer. And then what percent of MP3 players are sold for 80 or less at Lakeside? Now remember I said, don't forget about the numbers here. This is 25%. So each part of this is 25%. All right. This part would be the last 25%. But we want to know at 80, what percent? So this first is 20%, this is 20%, and then the whisker is 20%. So the whole box is 50%. And then plus the 25 would be 75%. All right, same type of problem, different set of data. Compare the center. So at Sparrow Down, we have a center of 5, which is greater than Hillsborough's of 4. The spread, Sparrow Down has 8 as a maximum, okay, and 2 as a minimum. So 8 minus 2 is 6. Hillsborough has 8 as a maximum as well, 1 as a minimum. So 8 minus 1 is 7. So Hillsborough has a greater spread. And the maximum value for Hillsborough is 8. And then what percent of the rainfall is 4 inches or less? All right, so we go to where 4 inches is, okay, and it's asking in Hillsborough. So that's the center. Now remember I said each part of this is 25%. So each half of the box is 25 and each whisker is 25. So if we're looking at that, that means that we've got the 25% there and the 25% there. So it would be 50%. And that's it. It's really easy once you get used to reading it. So, and again, no algebra involved. So you guys should do pretty well with this. All right.